Hello, welcome to my channel, friends. Today I am going to discuss with you chapter number 3 of geography, which is fundamentals of physical geography, and the chapter name is interior of earth. This is the NCERT books, chapter number 3, NCERT book of fundamentals of physical geography. और मैंने पूरे के पूरे इंटीरियर ऑफ अर्थ चैप्टर को 4 टॉपिक्स में डिवाइड किए हैं, जहाँ पर जो पहली 2 टॉपिक रहेंगी वो आपको बताएंगी इस लेक्चर के अंदर, लेक्चर नंबर 1 में। एंड बाकी के 2 टॉपिक्स है जो स्ट्रक्चर ऑफ अर्थ एंड वोल्केनोस एंड वोल्केनिक लैंडफॉर्म, इस सेकेंड लेक्चर में आपको पूरा डिटेल में समझाया जाएगा। सो मैंने क्या किया है कि अलग अलग सोर्सेज से लाइक NCERT, GC लियोंग प्लस माजिद हुसैन, इन सबको कंपाइल करके आपके लिए एक जगह पर सारे इन्फॉर्मेशन को ला करके मैंने रखा है। सो आपको इधर उधर जाने की ज़रूरत नहीं पड़ेगी, एकदम लेमन लैंग्वेज में सब कुछ सीखेंगे हम, राइट। सो लेट्स गेट स्टार्टेड। अवर फर्स्ट टॉपिक इज सोर्स ऑफ इंफॉर्मेशन। तो हमें अर्थ के इंटीरियर में कौन कौन सी चीज़ें हैं, कहाँ कहाँ पाई जा रही है, कहाँ से पता चलता है। Basically, 2 types of sources are there. The first one is direct source and the second one is indirect source. Under the direct source, there are 3 things like mining, drilling and volcanic eruption. When we mine a certain area, there are many type of minerals coming out, many types of rocks coming out, and through these we can make observation दैट क्या ये रॉक ज़्यादा गहराई में पाए जा रहे हैं, क्या उनका डेंसिटी हाई है, या फिर क्या अपन जब ज़्यादा नीचे जाते हैं तो क्या वहाँ पर प्रेशर इंक्रीज़ कर जाता है या टेम्परेचर इंक्रीज़ कर जाता है। सो ऑल दीज थिंग्स, ऑल दीज इंफॉर्मेशंस वी आर गेटिंग फ्रॉम माइनिंग एंड ड्रिलिंग, एंड थ्रू वोल्केनिक इरप्शन we can get the information about the interior of earth, like when lava flows out of the volcano's vent. So in the lava, different types of materials, different types of minerals which come out from the surface of earth, and after analyzing those materials we can get to know that what is present inside the earth, right? So these are the direct sources. Other one is indirect source. Under the indirect source, the first one is seismic wave, second one is meteorite, third one is gravitation, and fourth one is magnetic field. This seismic waves is nothing but earthquake. So through earthquakes, we can analyze what are the various types of zones present inside the earth. Like there is core, there is mantle, there is inner core, there is outer core. All these informations are dealt in the subsequent lecture downward. Fine. The second one is meteorite. As we know, meteorites are not the part of earth, right? Meteorites are coming towards earth, sometimes they fall on the earth, and through analyzing those objects, scientists are able to determine and define that what is present inside the earth, because both are made up of same materials, right? So meteorites also provide us information about the interior of earth. That's not the direct way, but yes, that's an indirect source, right? Under the gravitation, as we know that gravitation force is not same at every latitude. It is greater near the poles and less at the equator, right? So this is because the distance from the center at the equator being greater than that of the poles. The gravity values also differ according to the mass of the material. The uneven distribution of mass of the materials, right, within the earth influence this value. So we are also getting information from the gravitation, right? And in the magnetic field, as we know, there are northern lights, auroras at north pole, and there are southern lights too at south pole, which is also known as Australis Aurora, right? So the northern and southern lights determine the magnetic field. Why you can't see Aureolis at the equator? Because there is no magnetic field right there. And in the north and south pole, there are magnetic fields. That's why the rays coming from the sun, the magnetic fields are tilted like this, and you can see beautiful night, right? So these are the indirect sources which determines which are the source of information present inside the earth. Our main focus today will be upon earthquakes, right? So under earthquake, we are going to look around different types of places where different zones are recognized, like this place, this inside the earth. This is also known as focus. Let me take a pen. Yeah, this is known as focus. It should be noted here that focus is always below the surface of earth, not above the surface of earth. Focus is the place where two plates collide, right? Two plates collide here. And the nearest place from the focus is this, right? This place is the nearest place because this makes up 90 degrees, right? So this is also known as epicenter. Epicenter. Okay. So this is your focus. Focus is also known as hypocenter. This is epicenter, right? This line, you can see this. This is the fault line. Fault lines are mainly due to moving up of tectonic plates, right? These are the fault lines. This is also known as fault scrap. And you can see that these are the wave fronts. These are the wave fronts that is being generated throughout in 360 degrees. Okay. So under earthquake, we are going to take our discussion further. So there are three types of waves. Basically, there are three types of waves. Two waves are clubbed in body waves, right? And the third one is surface waves. So under the body waves are mainly generated due to the release of energy at the focus and move in all directions traveling throughout the body of the earth. Hence the name body waves, right? And the surface waves, the body waves interact with the surface rocks. These interact with surface rocks. And after interacting with surface rocks, they are known as surface waves. Okay. So under the body waves, let's look at P and S waves. P waves also known as primary waves, and S waves are also known as secondary waves. The special thing about P waves and S waves is that P waves can penetrate gaseous medium, liquid medium, and solid medium, all three of them. But the secondary waves can only penetrate through solid materials, and this is what makes us to determine the interior of Earth, because it can only penetrate the solid material. And as we know that the core has two blocks. This is the inner core and this is the outer core. So it is generally believed that inner core is solid and the outer core is liquid. Why so? I will discuss this in the next lecture, but for the time being I am telling you that outer core has density of 5 gram per centimeter cube, but the inner core has a density of 13 gram per centimeter cube. And this exponential increase in density makes the inner core solid and the outer core liquid. That is the reason why, as we can see here, P waves which can penetrate through all the mediums this P waves which can you can see here, this can penetrate every medium. This can also penetrate the liquid. Here liquid is there, here solid is there. So it can penetrate everything and it can reach even the other side of Earth. While in the S wave, which can penetrate only the solid material, gets reflected and diffracted from the path of this zone, because this is the liquid zone, right? So because core being liquid, the S waves are not able to penetrate here, and this is what makes here S wave shadow zone. Shadow zones are those zones where the tremors of earthquake are not observed, right? It should also be noted here that here P waves, this is the portion where there is no P waves reaching. Why so? Because as the waves move downwards, and the sudden exponential increase in density causes the waves to curve down and leave behind here, right? Because here density is very high, that the waves tend to curve, and due to the curvature of waves, we can see here that here P wave shadow zone also made. Similarly, when we put both the images above one another, we can see that here is 105 degree and here is also 105 degree. When we put both on each other, it should always be observed that P wave shadow zone, right? Here P wave shadow zone is also here. So this is the zone where you cannot find earthquake ever, right? So at these places, if you are taking your seismographic machine here, it won't be able to record any earthquake here, because it is a shadow zone of both P and S wave. वैसे देखा जाए तो S wave का shadow zone ज़्यादा बड़ा है, लेकिन ये जो एरिया होता है ना, यहाँ पर P wave भी नहीं पहुँच रहा है, राइट? S wave तो नहीं पहुँचेगा, लेकिन P wave भी नहीं पहुँच रहा है. And this spot makes both P and S wave so important. And the last is surface waves. As I have told you, that when body waves interact with surface rocks, they generate surface waves, right? So surface wave is very important, and it should also be noted that surface waves are the last to report on the seismograph, right? These waves are more destructive. They cause displacement of rocks and hence collapse the structure. Okay. So they are more destructive because they are the last to report also, and they are being subject to surface rocks, and surface rocks provide surface waves, right? So under the P waves, we will look around. Under the body waves, there are two waves, P waves and S waves, right? So the velocity of waves changes as they travel through medium with different densities also. The denser the material, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. So these two body waves, P and S, move faster and are first to arrive at the surface. This you all know, right? So P waves will reach to the surface before the S wave. Okay. And P waves are also similar to sound waves, as you know that it can penetrate all the three, and S waves are only able to penetrate the solid materials. And this has helped scientists to understand the structure of the interior of Earth. Reflecting causes waves to rebound, whereas refraction makes waves move in different direction. Okay. And it should also be noted here that these P waves vibrate parallel to the direction of wave, right? They vibrate parallel to the direction of wave, whereas S waves are perpendicular to the direction of wave, right? They, like wave is like this, then S wave will travel like this. They are always perpendicular to the direction of wave, and P wave is always parallel to the direction of wave. This exerts pressure on the material and the direction of propagation. As a result, it creates density difference, okay, in the material, leading to stretching एंड स्क्वीजिंग ऑफ द मटेरियल, एंड लास्ट में वो फिर स्ट्रेच होता है, स्क्वीज होता है, स्ट्रेच होता है, स्क्वीज होता है, और मटेरियल ब्रेक डाउन कर जाता है. And the direction of the vibration of S wave is perpendicular to the wave, as I have told you, in the vertical plane. Hence, they create trough and crest in the material through which they pass. So this is the speciality of S waves, that they create trough and crest to the materials through which they pass, and it makes materials elongated sometimes and sometimes shorter, right? And it should also but just keep in mind, the surface waves are also the most destructive waves, and they are the most damaging waves. Now I should also tell you that most of the earthquakes are tectonic earthquakes. These are generated due to sliding of rocks along a fault line. The special class of tectonic earthquake is sometimes recognized as volcanic earthquake also. However, these are confined to areas of active volcanoes, right? So let me show you a diagram. Can you see this circum-Pacific belt? This is also known as Pacific Ring of Fire, right? Why it is so hot? Because all the major small plates and important plates, like here also, here is also small plates, here is also small plates, and due to this small plates getting inside the mountains here near California and here at Peru, this creates here mountain ranges, here Andes also there. So these mountain ranges are created because these oceanic plates are colliding with these continental plates, and due to this, earthquake often occurs at this zone. You can also see that these zones are earthquake zones, and जहाँ जहाँ पर वोल्केनिक इरप्शन हो रहा है उस जगह पर अर्थक्वेक का आना ज़्यादा मतलब कि आसान हो जाता है. उस जगह पर अर्थक्वेक आता ही आता है, क्योंकि volcanoes are nothing but the movement of lava, and when lava is moving in the asthenosphere is basically the part of, this is the crust of earth, right? And below the crust there is asthenosphere. So when lava moves above it, it deflects like this. Okay, it goes inside and again it rises like this. So they are basically plates. These are the plates which are moving in different direction. As you can see here, these are Himalayas. Here Hindu Kush mountain is there, and here you can see that Turkey is there, right, near the Black Sea. So recently there was a huge earthquake in Turkey also and in Syria also. It was mainly because these are the zone of major and minor volcanic plates, right? Because Mount Vesuvius is here only. Vesuvius, this is a volcano in the Mediterranean Sea also. So these are the zones of major earthquake, right? So in the next topic, we will be discussing about what are the structure of Earth, right? And from the structure of Earth onwards, we will discuss in the next topic. Thank you.